So in this lecture we'll see another topic which is called as a scrambler. So the scrambler is a important part in communication engineering. Not only is a part of communication engineering, it is part of data communication network as well. Actually, there are many applications in which it is important to encrypt the data or randomize the data, and so that unauthorized user is unable to use that data. If he taps, if he is unable to get access, then he should not be able to see, because the information is important and confidential data for a user. Along with that, there are applications in which it is important to have proper clock recovery at the receiver, as we have discussed in the line coding as well, in the line coding section of this unit as well. So suppose we have a long string of 0 and long string of 1, and polar NRZ scheme is to be used. In that case, if we pass long string of 0 and 1 through something which is called as a scrambler, then what is going to happen is it will insert a randomized scheme at the output. It will insert randomized scheme at the output, randomized bits at the output. That is, a long string of 0 may be replaced by 0 1 1 0. That is, enough transitions are there so that clock recovery become possible. Or if long string of 1 is there, then if we apply this at the input of scrambler, then at the output it may become something like this. So these transitions 0 to 1 or 1 to 0, these transitions will occur at the output in the stream, so that clock recovery become possible. Now we will try to understand how these scramblers are basically designed. So given here is a structure of scrambler, and we will try to design corresponding descrambler. Scrambler will be present at the input at the transmitter side, while descrambler will be present at the receiver at the user end, at the other user end. As is the bit which is to be scrambled it has conventional meaning of randomization as well, and this is a scrambler device and T is the output. This actually is a sequence which is randomized sequence. Now can I write this as, now what is this? These are basically delay elements which can be implemented using D flip-flop. So what is the output here? It is T D Q. What is the output here? That this T is going into these delay elements so that it becomes TDQ, and further it goes into two delay element so that here it becomes TD5, and here what we get is TDQ modulo 2 addition TD5, and this is to be XORed with S, so that we get this sequence, we get this equation, that is S modulo 2 XORing TDQ modulo 2 XORing TD5, and finally we are getting this T, which is actually the output sequence. Let us assume that F be represented as D cube modulo 2 XOR D5. So rather than writing every time D cube and D5, we have assumed this to be a function F. If that is so, then this equation can be written as this, that is X modulo 2 XOR TF. Here again this d cube and d5 is replaced by function f. Now what if this equation, what if I XOR on both the side with TF? I can do that. I can in the left hand also I can XOR with TF. If I do in the right hand also, that is XORing with TF, then the equation is balanced. So this is what we will get. So from here we will get this x modulo 2 addition TF XORing TF, that is equal to T XORed TF. So now what is this? What is TF XOR TF? It is to be remembered, this is modulo 2 addition, that is why this is x modulo 2 addition 0, TF XORing TF is 0 and x XORing 0 is s. So we will get s in the left hand side, while on the right hand side we get this, and while putting the value of f in this we get this equation, that is x s is equal to t modulo 2 addition td cube modulo 2 addition td5. What I mean to say, if t be given and if I use this equation, if I implement this, then what I'll get is s. And what is this? So this is equation of something which is called as Scrambler. So what is this? This is equation of Scrambler. And what is this? This is equation of Scrambler. This is how we can obtain a equation of Scrambler from the equation of a Scrambler. We can easily design this Scrambler. We can easily implement this equation and design the Scrambler that we will see now. So what we have got is, we have got s equals to t modulo 2 XORing td cube modulo 2 XORing td5. So at the receiver what would be available with us is t. So what is this here? This is your td cube. What is this available here? This is our td5. And what is this available here is td cube modulo 2 XORing td5. And what is this available here? This is actually the same equation, that is t XORed td cube XORed td5. This is how we can get, this is how we can design Scrambler at the receiver with the help of Scrambler. So the question is, if a Scrambler be given, can we design Scrambler? The answer is yes, with the procedure which is discussed just now. So what is a Scrambler? Scrambler is a device. So I'll conclude this. What is a Scrambler? Is a device which is used for randomization. It is used for encryption. It is used in communication engineering for the purpose of inserting this clock extra transitions, so that clock recovery become easier at the receiver. And what is the structure? This is a structure. Structure may be different. That is, in this case, it may happen that only one delay element be given or only two elements are given. So this is a structure, and accordingly we can write this function which is written here. This is a function, and from here we can get the equation of Scrambler, and we can design the Scrambler as is done here. Now in the next lecture we'll take an example as to how we can find the output of a Scrambler if a sequence be given, how to find the output, and how to receive the same sequence at the output of Scrambler at the receiver. So two statements would be there. Number one, how to get the output T of a scrambler, and from T how to get the input S by applying at the input of the scrambler at the receiver. That we will discuss in the next lecture.